My name is Clinton. I'm the field CTO at Snyk, which, if you're not familiar, is pronounced like a pair of sneakers or sneaking around. Also sounds like it also is an acronym. It stands for So Now You Know. So hopefully at the end of the next hour or so, we'll all know a little bit more about what we mean by AI-Accelerated DevSecOps. Now at Snyk, we are a developer security and AI trust company. And I've been with the organization now about 6 years. I've really gotten to see a lot of the evolution in that time. Really moving past traditional or even legacy DevSecOps, which we're going to define here in a minute, and toward this new world of AI acceleration, and in particular, the need for AI trust. Before I came to Snyk, I had a long career as a developer, as an engineering leader, so I tend to think of these problems from the standpoint of how can we better support our developer experience within organizations, particularly when it comes to managing the new risks that we're seeing in both AI accelerated and AI native software. So that's what I hope to get into today. As Jared mentioned, please feel free to ask questions in the Q&A tab. We're going to get to those at the end of the presentation. I'm going to try to go about 40 minutes or so with the content, and then leave that last portion of the hour to answer questions and hopefully have a conversation around both this new world of risk and some exciting new opportunities we have in this new era of AI accelerated DevSecOps. So to begin, we have to kind of set the scene in terms of what are we seeing when we refer to the AI revolution in software development, and what are some of the effects that that revolution has, not only on our developers, but for the culture and the processes we need to implement in order to keep up with that new pace of software development before we even get into what are the tools that are going to be necessary to move us forward so that we can continually be moving fast and managing risk accurately at the same time. So there's really three trends we're looking at here. And the first one is mostly what we're going to be focusing on today. But this is the one that most organizations are already in, which is basically AI powers all software development across our organizations. And the word all is really powerful in that phrase, but I think it's accurate. If you think your developers are not using any kind of AI to build their software, it's just that they're not telling you about it. Whether we're talking about code completion tools, AI LLMs writing documentation, or even full-on agentic AI coding environments, AI is behind some form of all software development that is happening today. And that's been a rapid transition over the last 2 or 3 years. Moving forward from there, we also now see the effects of what I'll call AI native development. And that means utilizing large language models, building AI surfaces on top of our existing software, even training our own machine learning models, fine-tuning foundational models, doing retrieval augmented generation. So we can think of the first area as AI accelerated software, the second as AI native software, and then even a little further into the future, we have this third trend of software communicating with itself using AI, using natural language as the kind of API layer. That's a little further out, but we're rapidly seeing this transition away from traditional REST APIs and JSON as the deterministic exchange of data among software, and much more toward AI being kind of the lowest common denominator and interacting autonomously, whether you're talking about agentic frameworks like MCP or even more, traditional software that now has this LLM layer on top. So between these three trends, we're in a fundamentally different world in terms of how software is being built. Therefore, we have to secure it very differently than we would have in the past. Now, what's the parallel here? Let's think back in time as opposed to forward, and let's go back to a world maybe, 15 years ago, which, I certainly saw within my career. And if you were around at the time, we could have put up a slide like this that said, imagine a world where rather than waterfall-based approaches, software is built in rapid, agile, iterative loops. Instead of deploying manually onto bare metal servers, deployments were automatic, and we had continuous integration pipelines that did all of our building to reduce that risk. And instead of manually requisitioning, resources and installing things via very brittle processes. We had infrastructure as code, and we had containers, and we had the cloud that allowed developers to, write code to requisition their own resources. That marked a fundamental change. The combination of those three trends, agile development, DevOps, and cloud, really shook up the way software was being built. And that meant we needed a new security paradigm to match. So we're going to talk about that transition into DevSecOps as our kind of metaphor for what we're now looking at with AI, because that world came along with a lot of challenges as well. We had no concept of cloud security and what that meant. We didn't understand the importance of shifting left into developer workflows. We had all of this shadow IT happening. We had vulnerabilities hidden on containers that couldn't be scanned. We had legacy applications or legacy scanning tools and processes that required the security information to come after the fact, and that had to be modified to get fit into the developer workflows that constituted the new way software was being built. So we have a very similar story here with the chaos and challenges associated with AI. First and probably foremost on the minds of anyone in the DevSecOps space is the massive vulnerability rate associated with using AI to generate code. Now, this isn't necessarily AI's fault, right? A large language model is just a, predictive pattern matching tool based on the massive amounts of training data that are used to build the model. Well, where does that training data come from? It comes from human generated code, right? Which we know has a lot of vulnerabilities associated with it. So it's very hard to secure the code coming out of these LLMs when what it's been trained on is particularly vulnerable patterns. So the more training data you need to make more and more effective code generation tools, the less secure they get over time. But in addition to that, we have this massive change underway in terms of how the roles and personas within our organizations are interacting with software risk. We're going to talk a little bit more about this, but the idea here is that we no longer can rely on there being a relatively small community of people who have the ability to build software. In other words, developers. Now, essentially everyone in our organizations can become an app creator or software builder. What that means is we have to think in a completely different way about how we do security enablement and training and education, and how that new persona, which we've never seen before, has to interact not only with the tools that we're providing, but with our culture and process around securing software. Beyond that, of course, we have challenges around authorization, authentication, the new attack surface that comes from integrating all of these LLMs, things like the OWASP LLM top 10 new vulnerability threat vectors we have to think about, and of course, compliance challenges and lack of governance, or at least consistent governance, around how we're implementing AI in our SDLC. So we need the new evolution of application security, exactly as we saw DevOps, cloud, and Agile kind of come together to increase the speed of our legacy software development life cycles. And now, again, I'm old enough to remember back when we deployed software every few months instead of every few minutes. And that was done via very brittle manual processes onto bare metal servers that were in the data center, kind of owned by the company building the software. That's radically different now. But there was a period of a few years before DevSecOps, or developer security, came along to create that new security paradigm that we all rallied around. And again, those concepts of shift left, of secure by design, of integrating into the developer workflow, of rapid iterative fixing that was compatible with the way we organize our work in terms of agile development. So developer security, or DevSecOps, was the natural answer that allowed us to manage that new world of risk based on the additional speed we now saw. Well, what's happened since then? The world has changed again. We now have AI-accelerated and AI-native development. We need a new way to think about application security. So at Snyk, we call that new concept AI trust. This is the ability for anyone who interacts with software to have a sense of whether they can trust the output. But that means we need to radically reinvent the way we think about software security, just as we did when DevOps came along. And Snyk now is about 10 years old, so we were created in that initial push to build the DevSecOps community. Well, that's no longer enough. However, we can't just abandon DevSecOps. We're not just reinventing a new paradigm from scratch, just as traditional AppSec evolved into DevSecOps. This new world of AI trust needs to evolve from DevSecOps as kind of the natural landing zone. So we'll talk a little bit more about why DevSecOps maturity is actually more important now than ever, but how we need to change that idea to take into account all of the new context that's provided by AI acceleration. Let's dig in a little bit more into that role evolution point, because I think this is a great example of why thinking about the world in older terms doesn't necessarily apply to the way we have to secure our software now. Previously at Snyk, we would have had a slide here with two boxes on it, right? And it would have had security on one side and developers on the other. And the answer, of course, to getting those two groups to work on the same page was DevSecOps, shifting left into the developer experience, providing tools that were a more natural fit for DevOps life cycles, for securing cloud-based and containerized applications. But now that distinction is breaking down. And it's primarily because not only is security's role changing, but the role of the developer is rapidly, I won't say breaking down, but it's certainly transitioning into two distinct kinds of swim lanes for the developers of today. We'll start with security because that's probably the easiest transition. AppSec teams aren't going anywhere. As a matter of fact, they're probably becoming even more important relatively within organizations because so much more risk is now centered in our AI-accelerated and AI-native software. But what security teams have to do is transition from a role that's primarily based around gatekeeping or being reactive to vulnerabilities or slowing down development teams to ensure that scans can run to provide the trust for software moving through these automated pipelines, to now being a creator of policy. Well, why is that? Well, it's precisely because the speed of AI-accelerated development makes that reactive approach no longer applicable. We simply can't try to speed up DevSecOps without introducing AI and expect that it's going to keep pace with all of the AI-generated code that's now being pushed through our pipelines. The paradigm itself doesn't scale from the security perspective. So instead, what security needs to do is become a policy organization. They need to draw the map, determine what the risk tolerance is of the organization, and then implement that in a way that can be consumed by the other stakeholders in the organization. Now, those other stakeholders are not necessarily the developers of yesterday. It was very easy to say, well, security, creates the rules for developers. But now we've got kind of two distinct groups of engineers we have to think about. The first is the natural evolution of the DevOps engineer in our organizations is now much more becoming platform focused. So these new platform, or the other term I've been using is foundational engineers. You can think of them as the developers of today who decide they want to move down the stack. They want to actually get closer to the metal. They want to build the AI developer experience, or the really software builder experience, for the rest of the organization. So these are folks that, yes, they're focused on cloud and containerization and building pipelines, but they're also thinking about AI-powered developer environments, about how agents are interacting with each other via MCP frameworks within the organization, the relationship between the developer laptop or endpoint and the cloud, and how we're putting the right guardrails in place between all of those potential areas of risk. So security draws the map. Platform engineering paves the road that then software builders in the organization have to drive on. So that third group then we'll call app creators or software builders, which is distinct from saying they're developers because they might not even know how to write code. That's the biggest change in terms of how we think about the responsibility for software risk. We now have this community of people that can potentially introduce risk into our environments that don't have the understanding or the context of what they're doing at a technical level the way developers of yesterday would have to, because there was no other way to build software than write code yourself. Now I can go to an agentic coding environment and say, I want an application that does this. I can work with my AI agent in natural language to build via these native AI native workflows. So the platform engineers then are the ones that are responsible for building that foundation that other software builders in the organization have to work through in order to get new code into a pipeline. So then AI-Accelerated DevSecOps or AI Trust has to account for these new groups of stakeholders, these new personas. We can't simply extend the model of saying we have security on one side or AppSec and developers on the other, and we want a platform that communicates to both. There's three key roles in the organization now that AppSec has to account for. I often think of this phenomenon as like a sorting hat for today's developers. Once AI enters the picture, you kind of have a decision to make. You can either become one of these AI-powered app creators, a vibe coder, a prompt engineer, and this might even be somebody who previously was a product manager or a business owner who is primarily using natural language. They're interacting with AI surfaces that are churning out code that satisfies new functionality very quickly. But the limitation here is they can't necessarily ensure the quality or security of the code that's being produced. On the other hand, you have developers that decide rather than moving up the stack, they want to move down. They want to become platform or foundational engineers, provide and support the AI-powered experience for their colleagues across the organization who may or may not have the same level of technical skill. They're interacting more with the bare metal, which these days is things like CI/CD pipelines and Git repositories and cloud resources. But that means they have to understand the complexity of the underlying system. And that word understanding is going to become very important as we continue to tell the story here. But that means that this group of engineers has a different set of incentives. They primarily care about maintainability and security because they're the ones building the road that everyone else is driving on. And they're doing that based on the risk tolerance identified by the security team. So let's think through a little bit about this idea of developer experience. We understand how the personas are constructed: security, platform engineering, and AI-powered software builders. What does that have to do with this concept of creating a developer experience? Or maybe we should call it an app creator experience within our organizations. Well, this concept goes back quite a while, and there's been a lot of research done on what makes a productive software development team. It really boils down to three things. One of them is called flow state. Flow state is the idea that in order to allow the developers to do their most productive work, they need to be left kind of uninterrupted, right? They need to assemble context in their brain, and they need to make a series of iterative decisions based on that context. Well, if I then get a phone call or a Slack message, or I have to context switch out of what I'm doing into something else and then back in, that's a very expensive operation for me as an engineer. So developers are most productive when they're left in their flow state for extended periods of time. The second element of developer experience is cognitive load. And this is the idea that all of the information I need to make the next decision should be available to me kind of in my cache, as opposed to needing to go out and do additional research to make a proverbial database query, to open a new tab, to acquire new information. Because all the time I'm spending doing that, I'm not making productive decisions as a builder of software. And the third element of developer experience is feedback loops. So the idea is if I require feedback, if I can't proceed until I get an answer to a particular question, the length of time it takes me to get that feedback is very important. This might be something about how long does it take your code to compile until you can run a test against it to see if it satisfied a particular piece of functionality. But it might also be I need to revalidate a particular vulnerability that was flagged by my security team that I then need to make a fix in order to support. So all of DevSecOps, really, we can think about it is a security implementation of developer experience of these three core dimensions. The problem, of course, is that traditional application security tends to get each of these wrong. It interrupts developer flow state because those remediation requests are prioritized by security, not based on where they fit into developer context, so it pulls them out of that flow. It creates higher cognitive load because often security doesn't communicate why and how they're asked to make a fix. So I have to do additional research as a developer. And they create much longer feedback loops because the tooling often can't answer the question, what do I actually need to fix here? So I have to do another round trip out to my security team and back to ensure proper developer experience. Now, the interesting thing about moving to AI-accelerated DevSecOps is that we have opportunities to solve these fundamental friction points in how we implement AppSec on top of developer experience. We're going to talk through some potential opportunities to make that a lot easier. So when we say AI-accelerated DevSecOps, we're thinking about how can we solve this fundamental developer experience issue in the new world of using AI to both accelerate and within AI native workflows to build our software. So the best definition I can think of for that is that AI-accelerated DevOps means an autonomous platform, and that autonomy comes from introducing AI into our pipelines themselves for issue visibility, because you have to see everything to understand the context in order to make decisions about it. Seamless prioritization, so limiting that cognitive load by actually doing the hard work up front by collecting context, prioritizing it to present the best possible decision to the developer, and intelligent policy orchestration. That's how we integrate into the workflows of those three new personas to make sure they're being presented with the best possible information at the right time that's in accordance with the risk tolerance or the policy that was created by the security team. So AI-accelerated DevSecOps takes all of the best practices of traditional DevSecOps, figures out where they can be sped up and where there might be potential headwinds that are slowing down our DevSecOps processes, and then learning how to solve those through either cultural, process, or tooling-based improvements. So let's dive into that a little bit more. Let's think about the difference between legacy or traditional DevSecOps and what we see on the AI accelerated side. First of all, as we mentioned, historically, DevSecOps was created and scaled for human developer throughput. That increased substantially once we started doing things like GitOps and continuous integration and infrastructure as code. So DevSecOps is a set of methodologies designed around essentially the maximum extent that humans can, write code at scale based on that new set of technologies that started coming to market 10 or 15 years ago. Well, AI-accelerated DevSecOps no longer has that fundamental limitation. We have to think about how do we run developer security 10 or even 100x faster, because now the writer of the code is no longer a human. It's an AI-based tool or agent that can fill our pipelines much more quickly. So we can't let that be the bottleneck. We have to think about unlocking and decoupling our automated processes from the human scale that created the original paradigm that we're trying to evolve. Also, in traditional DevSecOps, we have scanning tools. We have a bunch of different kinds of scanning tools, right? We have SAST and DAST and SCA and container scanners and infrastructure as code scanners that are implemented in automated pipelines. The art of DevSecOps is implementing the right scanner at the right point to then make a series of deterministic decisions about whether to pass or fail a build based on very siloed set of contextual factors. And of course, this is the frustration point as well. It is what allows this automation to take place. But anybody who's interacted with DevSecOps at scale knows that it creates a lot of sticking points where you say that build should succeed, but it failed, and I have to work around it, or I have to make a modification to the deterministic set of rules that that particular scanning tool is using in the pipeline to decide whether to give me the red light or the green light. Well, what AI-accelerated DevSecOps can allow us to do is move past that very binary framework and think much more about the yellow lights in between. We can think about our pipelines not as a series of stop gates, but rather as an intelligent machine for resiliency and automatic fixing. The AI implemented in our pipelines can decide not just to pass or fail a build, but maybe whether a fix can be automatically applied. Maybe whether additional context means that something can be deprioritized, or maybe a ticket can be added to a backlog, or a comment needs to be added to a particular conversation to allow the security policy to be satisfied without interrupting velocity. And that can all happen within the context of a pipeline. So that kind of drastically changes the way we think about continuous integration in this move from legacy to AI-accelerated DevSecOps. Also, of course, we have lots of false positives, right? Within really the entire history of application security, that was maybe improved a bit with DevSecOps, but it's still a fundamental limit on how much trust we can have in the output of our security tools. And often that's because of lack of context. Well, moving to AI acceleration means we can prioritize our vulnerabilities based on more sources of context that are fed into this intelligent, resilient machine that now takes the place of our deterministic pipelines. And that's a very powerful factor that, again, changes the way we think about implementing not only our DevSecOps culture, but the processes and tools that support it. And then finally, again, if we think of legacy DevSecOps as a series of siloed single-purpose scanning tools, they don't talk very well to each other. They don't share context. There's no single point of understanding that then allows for predictive analysis to be made. This is often the case when you think about SAST versus DAST, right? You can have a scan that's run via static analysis that just looks at code, that gives a different result to the same kind of vulnerability once a dynamic test is run when that application's been deployed. So because those two tools are siloed and because there's no single frame of reference to communicate context between them, we end up with a lot of that traditional friction. But AI-accelerated DevSecOps doesn't have that limitation. We can potentially train our models to communicate between those sets of tools to create context on the fly and be able to do predictive analytics on software moving through our pipeline. To say not just, well, this is gated by particular response from your static analysis tool, but combining information from SAST from previous times the DAST tool is run, we understand the fix that needs to be made and we can implement that on the fly. So this is, again, a very drastically different way to think about DevSecOps that moves beyond its traditional limitations. So let's delve a little bit further into some of the really cultural and process changes that will be needed to implement this kind of new world of application security. The first thing to say here is that this isn't a sea change in terms of how we are thinking about securing software, so much as it's an evolution of what we've already been doing for most of the last couple decades in application security and software development. And we see that if we just simply look at the way software is being built. We didn't reinvent software development in order to make it AI accelerated and to build AI native applications. Instead, we built all of that on top of modern DevOps. There wouldn't be such thing as MLOps if there wasn't DevOps. We took that paradigm and we evolved it. So then AI Trust, the next evolution of AppSec, has to be built on mature DevSecOps. And this is exactly the way we think about it at Snyk when we're approaching a customer to do a services engagement around building their AI trust capability within the organization. As a matter of fact, we tend to think of the entirety of AI trust, the kind of four pillars that define all of the new cultural and process changes that are going to be needed to fully embrace not just AI accelerated, but AI native development. All of those we conceive of as resting on top of AI accelerated DevSecOps. So you can't do AI strategy and governance, secure AI design, AI trust assurance, or building your AI culture until you've got the maturity in AI accelerated DevSecOps. So let's take a look at that. Let's go down a layer and let's think about what are the capabilities of AI accelerated DevSecOps that we can then build on top of. So this starts out as a very traditional kind of maturity model for DevSecOps. We've got 6 pillars beneath that overall foundational idea. And this would have looked largely the same if we were doing this 5 years ago, right? Before the introduction of AI acceleration and AI native software really took hold, but also after we had, as an industry, matured the idea of what DevSecOps looks like. So forget the AI acceleration for now. Let's just talk through these 6 capability pillars of mature DevSecOps. First of all, you need your automation foundations in place, right? That means you need a DevOps responsibility model where teams understand how they relate to each other, how, say responsibility for the cloud is distributed between your centralized IT teams versus the teams building your applications. You need loose coupling of services so you're not locked into brittle monoliths that multiple teams are trying to work on at a time. You need to move toward a microservice type of environment that allows teams to move faster. You need everything as code, your cloud infrastructure, your containerization. You need to limit the manual brittle processes that are utilized in the absence of that kind of everything as code methodology. That leads to the idea of immutable assets that are built by reliable CI and CD processes, all of which can be measured so you can improve them over time. So before we even get to security, we understand what maturity in DevOps looks like. We then begin to build our DevSecOps strategy and culture. Do we have shared objectives around what that looks like? Are our incentives aligned? Do we have an ownership and accountability model associated with how software is moving through these pipelines? Really, one of the most important ones is, do we understand how we're managing our technical debt over time? This is where a lot of DevSecOps modernization efforts tend to fail. As you generate a lot of debt, you don't have an efficient way of burning down that backlog or balancing your tech debt resolution with your desire to build new features. And a lot of organizations get stuck because they never plan for balancing the one against the other. Therefore, they're unable to do both because the more debt you generate, the more difficult it is to then take time off from new feature development in order to burn that backlog down. And then, of course, we have to think about our security learning and enablement, our security champions program within our development teams to get them acclimated to thinking about security as part of their work. We think about secure software design, identifying our risk tolerance, understanding the requirements from a security perspective. Do we have a documented technology domain model and software asset inventory that informs how we do threat modeling? And are we constantly working on standardizing our application stack to make all of that threat modeling work easier, or at least more predictable moving forward? Once we've designed our software, we move into testing and monitoring. We shift left into developer workflows. We focus on developer adoption and the right kinds of coverage across our wide variety or diversity of technology. We think about whether our findings are accurate. This gets back to that traditional model of inserting the right scanners in the right places. And then we try to prioritize based on collection of all of that context, make it actionable for developers, and provide notifications that don't generate alert fatigue, but are actually proactive and valued because they lead to better decision-making at the right point of leverage within the software development lifecycle. We then move on to response and remediation. So we've tested, we're monitoring, we need a vulnerability management program to determine when we can assign things to backlogs versus when do we burn down within the context of a particular sprint, for example. All of that needs to be tied together with our issue tracking software and the workflows we're using among our engineering teams. Security needs to layer on incident response runbooks and game days that we need to be learning constantly from, doing our postmortems after incidents, and making sure we're using that as an input to update our processes over time. And then finally, we need to be constantly analyzing and governing our security program, gathering the right telemetry, making sure that we're tracking against the right KPIs toward our shared objectives that were documented and communicated, that we are reporting against our trends, particularly up to the business owners against particular well-defined SLOs. All of that is captured in policies and standards that are communicated transparently across especially our developer organizations, to foment this environment of continuous compliance. Now, I know that was a lot, right? And we can typically do a multi-day kind of deep dive on what mature DevSecOps looks like. But I wanted to pull out a few of these as we think about, well, what does AI acceleration have to do, and how does it potentially change this model of DevSecOps cultural and process maturity? Well, we can think of this as a combination of headwinds and tailwinds. When we add that AI acceleration piece, some of these potentially get easier, or at least they are capabilities that can be accelerated by AI, but some of them become more complicated. Let's take a look at a few of those. When we think about the headwinds, or things that might potentially get more difficult with the introduction of AI, reliable CI/CD becomes more difficult, because now we have non-deterministic factors introduced by all of those layers of LLMs that we're adding to our software. Threat modeling becomes more complicated, because now we're thinking about threats coming from each of those integration points of AI. We can't just simply map out deterministically what that application looks like. We have to think about the findings accuracy issue. Could we potentially get improvements from our AI tools in terms of how that accuracy is presented to developers? Can we collect more context to prioritize our vulnerabilities with greater accuracy and more trust? Can we make them more actionable over time? What does AI do in terms of improving our vulnerability management workflows? Do we have less overhead because we can use AI agents to potentially manage a lot of that backlog for us, especially if they're integrated with our issue tracking software and workflows? Does AI potentially make postmortems easier? And what about the compliance question? There's a lot of tools that can potentially speed up a lot of our GRC functions as they relate to AppSec. On the other side, though, there's things we have to consider that could slow down that process. We have to think about the immutability of assets potentially being challenged by the non-deterministic nature of AI and of integrating LLMs in particular. Our tech debt management is something we have to reimagine, because now we've got this whole separate category of AI tech debt that's a little bit more difficult to interrogate, because these machine learning models are black boxes. We have to develop new tools and new ways of understanding how much debt we're actually getting into in making those decisions. Security learning, we have to think more about, because we can no longer just direct it at our developer audience. It used to be that we could say, build a security champions program, integrate your security enablement directly into a developer workflow like a PR check or an IDE. Well, we now have this new community of AI-based software developers that aren't necessarily using any of those tools, or at least they're using them abstracted away by an AI agent. So how do we do security learning within that context of how these AI-powered software builders are approaching their work? This often means integrating directly into the decision-making loops, not just of the human developer, but of the AI agent itself. And we'll talk a little bit more about what that means. That obviously changes the way we think about shifting left, right? And identifying risk tolerance. How do we shift even further left than the human developer into the AI tools that they're using? Software asset inventory has to be updated to include our AI bill of materials in addition to our software bill of materials. And our AI or app stack standardization is really affected by the constant addition and changing of all of these LLMs and machine learning models. To say nothing of how much more difficult it becomes to create policies and standards around the use of AI and to communicate those transparently to all of our stakeholders in the organization. So we have a balance here of AI acceleration potentially creating challenges and providing new opportunities to modernize our cultural and process related workflows when it comes to building a mature DevSecOps organization. So to me, this question boils down to essentially saying who watches the watchman, right? We have AI that can potentially be providing our issue visibility, can be prioritizing our vulnerabilities, can be integrating into our policy workflows in order to potentially get us both the velocity of AI acceleration and what we want from the risk management side, more security at the same time. But it's not enough to say we'll just let AI solve these problems for us, because there's a fundamental limit to how much we can trust, in particular, these large language models, given that they are non-deterministic, right? That they're known to hallucinate, that there's an inherent uncertainty problem that you can't potentially solve just by integrating more and more LLMs on top of them, to say nothing of the cost that involves, right? When you're thinking about tokens and GPU cycles and everything else. So we do have to use the right tool for the job. But it can't always be a human in the loop. When we think about all of those aspects of DevSecOps that can be accelerated by AI, there are a number of ones that are potentially slowed down as well, right? Because we can't simply say we want AI acceleration, but we want a human to be verifying everything, because then you get the worst of both worlds. You've got hallucinations coming out of AI that you're forcing your human developers to correct. So you're losing the velocity benefits that come from utilizing AI in the first place. So more important than this distinction between human and artificial intelligence is the idea that you have some level of understanding. And what is understanding based on? It's based on context. So how can we use AI to intelligently, no pun intended, integrate the right amount of context to lead to the right amount of understanding within our pipelines to make the best kinds of decisions? So this is an area where we can think about different kinds of AI that all have a role to play. And in particular, one very rudimentary area of AI research is all around symbolic intelligence, as opposed to the semantic intelligence that we get from a large language model. Symbolic AI sort of does the inverse. Rather than analyzing a large amount of data to pull out the patterns, it starts with this set of symbolic rules and is looking for them inside sets of undifferentiated data. So this is actually potentially great news for our engineers, because we have some tools that we can integrate to potentially inject some context and understanding into our DevSecOps processes that don't always need to involve a human engineer babysitting every PR, every continuous integration run, every suggested fix. But that does mean we need a new way to think about the craft of writing software. Who are the responsible engineers, and what information do they need to provide that accountability that fundamentally AI can never give us? So let's think a little bit more about what that model could eventually look like. And to provide one example of the use of symbolic AI to backstop the potential for hallucinations, this is actually the core value proposition of the deep code AI algorithm or model that's at the core of Snyk code. So our static analysis engine is based on not an LLM. So not using an engine that's analyzing the semantic reading of code, but rather it actually parses the application into these abstract syntax trees, which is then how we train the deep code model on looking for vulnerabilities using the input of the Snyk vulnerability database that comes from the world of open source software. So we have these semantic facts that are layered on top of the abstract syntax trees that are extracted from our static analysis scanner that then allows for much greater accuracy in terms of determining whether a vulnerability exists or not. So this is kind of an inversion of the way typical static analysis works. We're using AI to drastically speed up and provide greater accuracy on top of this new velocity of machine generated code. So it's using AI to potentially mitigate some of the risk of AI. But the key distinction here is you can't just use a similar kind of technology to do both jobs. You can't rely on an LLM to secure itself because you're not injecting additional context and understanding into that loop. So this is just one example of a technology that can potentially accelerate DevSecOps via the use of AI, but it's not just saying, well, we have to blindly trust the output of all of these large language models that fundamentally are often based on the same set of underlying training data. So we know that legacy security tools can't provide AI trust. We need to kind of reinvent the way we're thinking about the relationship between builders of software and security. And I think there's three key ways that this new world is different. The first one is this issue of non-determinism, because security itself has become probabilistic. So this new AI trust platform or AI-Accelerated DevSecOps fabric has to know everything that's knowable about a piece of software, and it has to make educated and repeatable assumptions about what isn't. This is where that idea of predictive analytics comes in, because we can retain that context window across, say, multiple PRs or multiple CI/CD pipeline runs so that these assumptions become more educated and more repeatable over time. Once we understand that non-deterministic situation, we can think about the decision-making loops that are now happening much faster because of the rise of agentic AI. So typically, and this concept of OODA loops comes from military strategy. The idea is that in order to make a decision, I actually have to do four things. I have to observe, orient, decide, and act. Well, if the other entity that I'm collaborating with has already conducted that entire loop while I'm still observing, I can never orient, right? So I can actually have to get inside the decision-making loop in order to meaningfully collaborate with whether that's another person or, in this case, an AI agent. So what AI-Accelerated DevSecOps needs to do is to get inside the decision-making loops of the AI agents that are making decisions about code without slowing them down. It's a fundamental challenge that legacy AppSec does not support. And then finally, we have to think about secure at inception. This is the idea that reactive security, traditional AppSec of we build a bunch of software, we run scanners against it, we find issues, and then we fix them. It's no longer a workable paradigm. We have to instead think about guardrails that are integrated from the beginning, from the design or inception phase of software that govern the creation process itself. So again, three fundamental ways we have to shift our AppSec practice to now keep up with the new needs of AI accelerated and AI native development. So let's kind of, as we're concluding here, think about what are the three engines that are ultimately going to be required. We've talked a lot about culture and process and the updates that we need to make there. How can we think about, from a tooling perspective, what we need to evolve to move toward this AI accelerated DevSecOps future? Well, I see these capabilities largely falling into three buckets or three engines of what we need to ensure AI trust within our DevSecOps pipelines. First of all is what we call the fact engine. The fact engine just learns everything that's knowable about software. This is our traditional kind of SCA scanner, our software bill of materials, all of the assets, in particular the AI assets that we're utilizing. So this is the simplest one, but AI can accelerate the process of analyzing a given code base or software asset to tell us what's inside, what are all the knowable facts that allow us to make assumptions. That then is handed off to the flow engine. What the flow engine does is make some of those assumptions about risk in software and remediation by constructing those flows. This is where that Snyk code or deep code AI comes into play. This is where we think about static analysis. We also have to think about now things like MCP security. How can we model the flow of data within a piece of software based on the facts we've determined to then make informed decisions about risk and remediation? When we've modeled those flows, the final step in the process is what we call the threat engine. And this is the idea that we test those assumptions that the flow engine generated based on the learned facts, taking all of that context into account, and then determine which of those threats actually succeeded or failed. This is where we think about dynamic analysis. We think about red teaming, about penetration testing. But in traditional DevSecOps, to the extent that all of these happened, and they did on some level, they were largely siloed. They didn't communicate with each other. The big improvement in AI-accelerated DevSecOps is that this now becomes kind of an unbroken loop that sits at the core of our application security practice. Because once that threat engine is done running, once we have a dynamic analysis result, what does that become? It's a new fact about software that our fact engine can then process to be able to allow the flow engine to make better decisions, to allow the threat engine to more succinctly provide tests against those perceived threats. So all of this comes together in this idea of AI-accelerated DevSecOps leading to trust, because you have AI at the core of each of these engines, communicating freely with each other, developing much better understanding of what the software is actually doing, how to secure it, and ultimately what remediations we need to make in real time. So there's lots of opportunities here, right? If we kind of now look at what are some of the potential new capabilities on the horizon within this world of AI-accelerated DevSecOps. We already talked a little bit about context-aware automatic remediation. So those engines working together to decide there's an improvement that we can make to this piece of code to allow it to move through a pipeline. We don't have to put up the red light. We can simply append and move on and increase our velocity as a result. Smarter scan coverage. This is the idea that you don't simply have to waste time running every siloed scanning engine against every line of code. We can intelligently decide which code or which repositories need the right kinds of scanners run against them to collect the right kinds of context. We're not duplicating information. We're using the right tool for the job based on that AI analysis. We have new abilities to do things like reachability analysis. What vulnerabilities in your open source dependencies are actually reachable because they're executed at runtime? We can utilize runtime data streams to determine whether particular upgrades are going to break that piece of software or not, and collect all of that together in a single decision in real time in our pipeline. So reachability, breakability, drastically accelerated by AI. We can improve the accuracy of our DAST tools in terms of the way we fuzz our prompts for that threat engine. We can think about logic-based vulnerabilities that have been very hard for DAST tools to diagnose, like broken object level authentication or BOLA. And we can associate now a fix with a dynamic analysis result, because ultimately what AI can allow us to do within DevSecOps is to correlate findings between different kinds of tools, particularly between our static and dynamic analysis results. We can do that. We can actually have high accuracy that comes from DAST, as well as the fixability that comes from static analysis at the same time. We can break down those silos between our tools, and we can really allow the full power of both the velocity we get from AI acceleration and the risk management from traditional DevSecOps at the same time. So what are some takeaways? We learned today that AI acceleration requires a new security paradigm. The legacy methods we had that are focused on gatekeeping just don't scale to this new technical reality of how we're now interacting with software and managing its risk. We learned that context is the new code. The success of these AI-accelerated DevSecOps methods depends on managing technical context, collecting it from multiple places in that SDLC and running it through those three engines to constantly develop better and better ideas about where that risk is coming from and how to mitigate it at scale without just relying on these sort of red and green lights. We learned about developer experience and how that actually has to be preserved in this world of AI, because it doesn't mean developers are going anywhere, but it actually means their role becomes more important, not less, particularly as they're evolving into either AI-powered vibe coders or spec-driven developers on the one hand, or these kind of more platform or foundational engineers on the other that are going to have security as a more core element of their value proposition. So we have to continue thinking about how do we preserve developer experience in this AI accelerated world. And finally, we learned that we can have high velocity and high security at the same time within DevSecOps by using AI to speed up certain parts of the process to unlock efficiencies that we've previously not seen in AppSec to give us that accuracy at the same time. But only if we first address the cultural and process factors that could potentially slow us down. So it's a complicated problem. We have to approach AI accelerated DevSecOps through the lens of mitigating the potential headwinds and embracing the potential tailwinds, which then unlocks this new world of AppSec capabilities that, frankly, we've been dreaming about for a very long time. So I hope this has been useful. I know I went a little bit longer on time than I was intending to, but hopefully you've learned a little bit about this world of AI-accelerated DevSecOps leading to a new world in which we can trust the output of our AI-accelerated and AI-native software development process.